Well, hi, good morning. Thanks so much for coming and keeping me company here on, hey, it's November 1st. Oh my gosh, it's November. What happened to the summer? Seems like I spent the whole summer getting ready for the summer and then it disappeared. That's how it feels anyway. Now I'm getting ready for winter. So what are we going to do with this radio? The radio is working. Its performance is kind of poor, but you got to wonder, how well is this radio supposed to perform anyway? This is a very simple radio. They don't get much simpler than this, really. And so consequently, the antenna is essentially connected through a transformer right to the grid of this mixer tube. A better radio would have another tube ahead of that, an RF amplifier tube. It would give the radio much more much more of this. Hey, where's your words, Jim? But this one doesn't have that extra tube. So, in fact, let's start by testing the tubes in this radio and see if they're weak. So, this is the mixer tube here. That's a 12 SA7, and we're going to pop it in my tube tester over here. This is a pretty good tube tester. Quite reliable. I have no reason to doubt it. I have other tube testers. They all compare. They're really good at finding a dead tube, that's for sure. 12 SA7. So I'll let you watch this process for the first tube. So we got to find 12 SA7 in one of these lists. I think it's going to be over here. 12 B, C, D, 12K. 12 SA7 right there. Okay, so first thing is we set the supply voltage to 13 on the dial. The signal level is set to 2. Bias is set to 9 L. L for low. And the switches are 2, 7, 3, 4, 5. 2, 7, 3, 4, 5. Now if you see me make a mistake, let me know right away so I don't test the tube wrong. Bottom row 1650. 12 SA7. 1650. Okay, did I get those right? Well, I don't hear anything, so I guess so. Okay. 45 on the cheater C plate switch. Now this tube will measure 1100, and this tube tester is testing the whole tube at once. 1100 is about there. Okay, switch it on, check the voltage, it's correct, plug it in. So a lot of these small radios have the same lineup of tubes, or nearly the same lineup of tubes. They're very common. This tube's quite common, 12 SA7. So for sure I have replacements if this turns out to be a dud. First thing we want to do is check for shorts, or leakage as it says, between the elements inside the tube, in case the tube elements have actually touched. Now, the radio works, so the chances of one of these tubes being really bad is really low. But how good is it? Okay, so we're going to test. I have another camera shot here. You can look more closely at the meter itself. So 1100. Now 1100 is the reject point. If it doesn't get above 1100, I'm supposed to sell a new tube. Here we go. Wow, okay, there's not a problem with this one. That's a beauty. Okay, let me just double check now, because the reading was surprisingly high. Just double check some of these settings. 9L, correct. And the switches, I'm sure, are correct. 2, 7, 3, 4, 5. 1650. You get the switches are on, the result is pretty dramatically. 45, everything's set correctly. That's a really good tube. Okay, let's go on. I'll set up for the next one. Okay, let's double check. 12 SK7. It's very easy to read the wrong line over here and put in the wrong values. It's very easy to let your eye slip. That's why I have my finger here. 2, 10L, 17253, 1725. It's a 1. That's a 1. That's correct. 4630, 4630. Okay, in you go. This tube, this is a 12 SK7. Where do I want to go in? Okay. This is the very important tube for the radio in terms of its ability to amplify the radio signal. Excuse me. It's right between two IF transformers. It's a very controlled environment in there, so they can maximize the operation of this tube and get the most out of it. This is where the gain in the radio mostly comes from. Okay, let's see if there's any shorts. We need to do this test mostly to protect the tube tester. Excuse me. Is the plate C? Did I check that? Yes, C. Okay, and now this tube should test 1520. So, wow, that's way up. Well, 15, just above the halfway mark. Okay. Here we go. 1520. Wow, look at that. Way up there. Okay, so I'm going to do a little sensitivity study. I'm going to wiggle the meter sensitivity setting a little bit. It doesn't take much to make it move a fair bit. But to get it way down here, it's not. So what I'm doing is I'm just looking here at bias, a little bit of bias. Bias doesn't make much difference. So, just curious sometimes about how precise the settings have to be to get some kind of valid indication, or could it be the case that you set this a little off, you set that a little off, and the result is you get a totally false reading? No, that doesn't seem to happen. Okay, another good tube. We're only left with one more to test. This is a tube that plays 2 roles in the radio. I'll pull it out here. 12 SQ7, another very typical tube to be in these 5-tube radios. So this guy's job, he's got an RF job and an AF job. He's got a radio frequency job and an audio frequency job going on. It's really 2 tubes contained in one. This is what it really is. I'll stop talking for a moment. 12 SQ. 12 SQ. We are. There's 2 tests on this one for the amplifier part and one for the diode part of the tube. First test is going to be on the signal part. 13 voltage, signal level 1, 18 low. Yeah, I'm going to make you watch this. 25100, 25100, 3760, 3760, 37 on the cheater. See, when you test a tube, when they make these tube testers and you're testing a tube, they really want the meter to be operating in this kind of range. They don't want to set it up so one tube, a good one, tests way down here, and another tube, a bad one, tests way up here. They want it all to be kind of similar. Cheater control to achieve that. That's what I say. Okay, A for the plate. Did I fall off? 37? I did not. F for the plate. I did. I read the wrong line. Okay, so this is the triode section of the tube. We can pop it in now. So after the radio has recovered the audio from the RF signal using the detector, using the other part of this tube we're not testing right now, Then this tube amplifies the audio to a level that's good to drive the output tube. So it's providing a certain voltage swing onto the grid of the output tube to get the most out of it. That's its job. Often this is hooked right up to the volume control. So the volume is controlled going into this tube, into the grid of this tube. Okay, should be ready. Let's go. Very good. This test should come up 760. So 760, it's got to beat that. It's got to beat that spot. Now let's take a closer look here at this. There, isn't that better? Okay, here we go. 760. Oh my gosh. Oh my gosh. It doesn't get any worse. Okay, now a couple possibilities here. One, I've got the machine set wrong, so I'm going to double check all the settings very quickly. Signal level 1, 18 low, 25100. 25100. Anytime I get a wild reading, I always double check this stuff. 37, or unexpected reading, 3760. And I get a reading on a tube being bad, I don't throw it away right away. I do everything I can to resuscitate it in the sense that my test is not valid. I shouldn't have said resuscitate. I don't try resuscitating tubes. There are some tricks you can do that kind of bring them back to life, but you're basically flogging a dead horse is really what's going on in most cases. 760 is the rejection point. Okay, let's hit it again. Oh. Okay, another possibility is that the tube itself is not seated in the socket properly. So I'm gonna wiggle the tube here. No, I don't have that problem in this socket. So other tube testers have difficulties with their. It's a dud. Wow. Okay, well we'll do the diodes too. Let's do the diodes now. In this tester, I think you need to pull the tube out when you change the settings, the main settings. Okay, the diode, this doesn't matter. This doesn't matter. To test the diode, 2013P. 2013P. 0760. 0760. 48. To get the meter to behave nicely. A. That's a Canadian word. A. P1 and P2. So there's two diodes in here. Test one with the switch in one position and test the other one, plate 1. Switch it to plate 2 and test the other diode. We didn't look at the schematic to see what the radio designers did with the two diodes. Sometimes they use both. Sometimes they use one for ABC, one for the audio. They do different things. We don't know. Let's see what happens here. Tube in. A moment to warm up. Oh my gosh, you've been staring at the meter while I've been talking. Well, keep staring at it because we're almost ready to. Okay, here we go with the leak test. During the leak test, you're reading this bottom scale here. It says leakage. And that actually gives you the resistance of the leak. 500K, 1 million, 5 million. And the fact is, it always jumps up a tiny amount. So I don't know why that is, but it's nothing to do with the tube. Now to do the test, I throw a different switcher, a rectifier, and diode test. All it's got to do is get into this diode's OK zone. Okay, we'll test the other one. I'll throw the plate switch and the other one. So we've got a tube here that is showing weakness on all fronts, especially the amplifier part. So this tube will make a difference if I replace it. The others, no, the others are good. So got to get another 12 SQ7. Great. And I have a pile of those guys. 12 SQ7. See some of my tubes down here. Those are the popular tubes that go into radios like this. That's what I keep in my shop here. Let's get them out. I've been very fortunate at building up a pretty good tube collection. So these are all 12 SQ7 tubes. I got a pile of them. Some of them you see have a label. They've got a green label. That's because I've already tested them individually. But I'm going to grab one without a label. Now that's a nice looking tube. Let's see if it's a nice looking tube. I'm going to test it. I could grab a labeled one. But why do that? So we're set for the diode test. We'll do the diode test first. So I'm unaware of whether this tube is good or not. Well, it should be good. The only tubes good in the sense that the heater is good and it conducts some current. I don't know about its quality. If it were dead, it wouldn't be in that. My bucket there would be in another great big box full of dead tubes. Maybe 1,000 dead tubes or something crazy like that. Okay, checking for leaks. None showing. Okay, I'm going to do this button here, and it's right up in the diode zone. And you can probably tell that. Plate 2, a little lower on this one, but still within the OK zone. Now we want to do the amplifier test. And don't mix these tubes up. This is what I do all the time. Get things mixed up. Okay, so we're going to go back to the other test. So 1, 18L, 25100, 25100, 3760. Okay, 37, 37. F. Don't get that wrong. Okay, back in it goes. This can have quite a dramatic effect on the radio. I think the weak diodes might. Well, I don't know what to tell you. The truth. I have ideas about the effect of this tube. What it would do. When the tubes get weak, the operator turns the volume up higher and higher to compensate, not even realizing that's what's going on, unless the volume goes way up towards the limit. And as you do that, more and more unwanted stuff becomes apparent. You're amplifying a bunch of unwanted stuff because the signal you're after is so weak. Okay. Did I already do this? Oh. Okay, let's flip here. Now. So in position 3, we get that. This is a proper test. Whacking the tube. Well, it's got a fairly stable leak of 5 mega ohms. Leak, probably not too significant in operating that tube. On the so there's. I could, if I took the time, look up what position 3 is, and it will tell you what the test is actually testing, where this leak is occurring. You know, is it from grid to what, or plate to what, or whatever. But I don't think I'm going to do that. I think I'm going to lay this one aside. I would not throw it out. Okay, I have another one here. 12 SQ7, again, not labeled, so don't know the conditions. We'll pop it in. And we'll see what this one comes out as. Could you use this in a radio? Well, I guess the only way to really know is put it in there. Now, how would you know that this leaky tube is in a radio? It'd have to be bad performance of some sort. Would the performance be bad enough that you could say, oh, it's this tube and it's leak? I don't think so. Not at 5. Not at 5 megohms. this up here. I shouldn't have. No leak showing. And we're testing at F, just double checking here. Yes. 7. Oh, it's a beauty, because it's only supposed to come up to here to reject it. It's in a more like a light new sort of condition. Very good. Let's just do the diodes to be sure. So we'll go back and forth here. 201 2013P, right? 2013P 0760 0760 48 A. It's that Canadian word again. Pop it in. There's a lot written here. Oh, that's because I'm reading the wrong line. There's not a lot written here. Okay, we'll look for leaks again. Nothing. Okay, watch the meter. Here we go on rectifier and diodes. It's right up there. Okay, I was plate 1, plate 2. A little lower, just like the other tube. A little lower on plate 2. Makes me wonder if that's the tube tester. This guy's the winner. Okay, we now have removed a very, whoops, got my camera in the wrong camera here. A very sick tube from this radio. And we're going to replace it with a good tube. Let's see what kind of difference it makes. Okay, well, again. Switches off. They're in business. Here we go. Watch the dim lights. Watch the meter. You can watch this meter. The meter is showing the voltage. That's it's showing what's left of the 120 volts that's reaching the radio, if you know what I mean. Here we go. This is a 100 volts at the bottom of this meter, by the way. It's not a 0. So we're up around 110 according to the meter, but probably a little less. Okay, but that's all operating normal. We will flip to full power. Full. Here we come. We have to use our memories to compare. Now the ticking sound, that's not from the radio, that's an actual noise signal coming in. Too bad it's there. So this noise signal is so powerful that it's going to be cutting back the AVC, or cutting back the sensitivity. It's going to desensitize the radio. It's right across the band for the most part too. There's other noise signals. I can null out the interference here. Let's go back. That's new. It's definitely working better. Let's try the 680. So no, on the 680. 680 is a weaker station that better radios can pick up. If it had that extra tube up here, it would probably pick that station up. Okay, so that's the situation now. We've eliminated one bad tube and seen a bit of an improvement. I don't think there's any reason to check the rectifier or the output tube just yet. There's lots of volume coming out of the speaker, lots of volume. So in a sense, the tubes are checked by being in here. So what we want to look at now are some operating voltages that are reaching the different tubes to make sure plate voltage is correct, and for the tubes that have it, the screen voltage is correct. And also we want to check the grid voltage on the output tube to make sure it hasn't been pushed positive by a leaky capacitor. That's what's next. But now, coffee time has come. And in fact, I got to make a trip to the grocery store at this point. Oh, yeah. Okay, back from the grocery store. So what I want to do now is check the key higher voltages on the tubes here. In some cases, it's just a plate voltage, and in other cases, it's going to be a screen voltage involved. And in the output tube, we'll take a look at the grid voltage. Use this meter. Better set it up a lot higher. We'll start at 500. I'll read the power supply output voltage right on the top of the supply capacitors to start with. Okay, I guess we need to turn this on, don't we? There we go. So I have my meter ground wire connected to the B minus in the radio, the B minus bus. Just give it a moment here. Okay, watching the meter on the 500 volt scale. What do we get? So that would be 150 volts. And this other capacitor, ooh, it's very, very low. I don't think that's quite normal. So this is a 150 volt scale now. 75 volts. Seems unnecessarily low. Okay, so that's what's happening with the power supply. We have to study this a little more carefully to sort out what's happening. Let's go on the tubes here. This is kind of a jammed up radio, isn't it? Wow. Let's start with the first tube. I get a little bit of sound out of the speaker when I do this. First tube. Which pin is, so the first tube has a screen and a plate. So we should find high voltage on two of these. I'm just going to go right around. I'm not even going to check, the pin out. I'm just going to. Okay, there's one there. So that's 75 volts. That's probably the grid there. So that's a wee bit of a negative voltage there. You probably can't see the meter moving, but it's actually moving in the negative direction. My zero's off just a wee bit. Let's go around again, because that shouldn't have worked out that way. Here we go. 1, 2, 3. There we are. I guess I just missed it first time around. Both of these are at 75 volts. Well, I think there's a problem. I think one of them should be closer to the 150. They should both be closer to 150, in fact. Okay, we'll go to the next tube. Just again, just hunt and peck. Same 75 again. 75. Nobody's got the 150. It's a little bit of a tough terminal here. Got the two high voltages there. Okay, we're down to this next tube. Just start here. It's a tiny positive voltage there. A little odd. Ooh, now that's what I would expect on the plate of all these tubes. There's the 75. That might qualify as normal. And I shouldn't find any more voltage anywhere. Ooh, scary. Here we are. It's right off the capacitor again. So it's possible with these tubes, sometimes not every pin is active from the tube point of view, and the pin becomes a opportunity for the radio designer to make connections to it, like just like a terminal strip. That's confusing when you're doing this kind of work. Okay, down we go here. Wow, this is just really crowded here. Let's just try here. A little bit of a strange behavior on the meter. That might indicate this is actually an AC voltage here. I don't know if we can get there. Seeing through a thing. This is right on the power cord. This one right here. Ooh, scare me. Don't scare me there. What just happened? Radio's operation changed. Got this wooden block with a screw sticking out. I may have touched the screw and then touched the terminal. I may have grounded the terminal to the chassis briefly. But briefly shouldn't do much. Something changed in this radio when I did that. And the last terminal's behind there. Well, that's enough already, I think. That's, you know what? I think that's the rectifier tube. I shouldn't even be doing that. Shame on me. The output tube is here. No, that's not the output tube. This is the detector tube. Much lower voltage there. On a 150 scale, that's about 40 volts. 35 volts. Here. The rest of them are really. I might get out of it. I don't want to stick my probe in there, I don't think. It's just too much chance of shorting stuff out. Well, that definitely suggests that something's not quite right in terms of these voltages. Oh! I gotta run. Okay, it's been a day of distractions here. So let's just look at this first tube, the 12 SA7 rather. One pin we get 75 volts, and on the other one we get 75 volts. I don't think that's right. Let's take a look at the schematic and see if we can sort out what voltage. Wasn't there a voltage table in there? I think there is. Yeah, right here. Okay, so we'll start with the 12 SA7. And there you are, 72 and 72. So that's actually correct. 25 now. Let's see, indicates AC volts. Not worried about that. Down to B minus. So, you know, all those voltages I read were probably correct. Let's look at the output tube. 50L6. Plate has 113 volts on it. We need to check that. That's pin number, what are we looking at here? We're looking bottom view of chassis. So we count 1, 2, it looks like 3. Pin 3 on the 50L6. Okay, let's check it out. Oh, wait a minute. Another one I should make a note of right now. On the 50L6, the grid. 1, 2, 3, 4, 5. So we have plate, screen, and grid. High voltage, 72 again, and the grid. Let's see if this voltage shows up on there. Okay. Okay. So we get the right tube. It's this one here. And the pins were, Mr. Short Term, I can't even remember 2 seconds here. The pins were in 1, 2, 3, 4, and 5. 3, 4, and 5. Okay, let's see what happens here. 3, 4, and 5. 1, 2, I think this is 3. Hey, meter. This is 3. This is 3. So what we would expect on there, according to the schematic, was 113. And we're getting 65. And the next one should have the 75. And nobody's home. Something going wrong here. Something is going wrong. Maybe I've counted the pins wrong. Counted the pins wrong. Okay, let's try again. So this is 3 here. That's what we want to see. High plate voltage. The actual measurement there is 135. And then we have the screen, which is good, around 70 or so. And then the next one is the grid. Doesn't make much sound, does it? Doesn't show any voltage there at all. So we need some kind of signal, even a noise signal. No, we shouldn't need any signal. We shouldn't need anything. No grid bias on the output tube. Is that what I'm finding out here? I think that they're very sensitive. So it's going in the wrong direction. It's supposed to go negative, not positive. It's a capacitor right here. It's the same connection. Maybe this guy is leaky. Let's check the other side of this. So the other side of this would be a plate. Maybe. So we've got, that's a little low too. We've got 35 volts here. And it should be 45. Voltages are all over the place. We have 35 volts on this side of it, and on the other side, we should see nothing. We get that. That looks a little higher now. So that's about, so this is a 1.5 volt scale now, so this is half a volt positive. Not good. So either I'm making mistakes here, or there's a problem with this capacitor right here. It's leaking. So some of the voltage on the other side is making it through to the grid. Let's take a look at the schematic here for this guy. What's all that noise? Okay, so if we look at the schematic and look at the output tube, how is it getting biased? So So this is probably the leaky capacitor. It's leaking some voltage from here. Why are you noisy, radio? And it's getting onto the grid. Now, how would the grid be biased otherwise? And surprising to me, it looks like it's just self-biasing. So this is B minus. R7 is probably fairly large. Do we have a chart that shows that? They put the values down here. This is the different version of the same radio. So yeah, fairly large, 500,000. So this is probably 500,000. And that's why a small charge leaking through here can push the potential up. But this should be driven negative. There's usually a capacitor associated with it somehow. How are they biasing this? What am I missing? Cathode resistor. That's what I'm missing. Okay, I'm okay now. So here's a cathode resistor. This guy is probably like 150 or 200 ohms. 150 ohms. So that guy is providing the bias. And he's doing it by pushing this, making this positive, a little bit positive. So relative to the grid becomes negative relative to the cathode. So we need to measure this voltage. And then this is robbing, because of the leak here, this is being pushed a little bit positive, so it's going to rob away some of the negativity. Let's measure this across R8, or what pin number is that? I don't know. I have to get out my book here and take a look. Let's take a look. 50L6. 50L. L6. Next, typical operation. Plate supply with fixed bias, 110 volts, with cathode bias 200 volts. Well, there's no 200 volts in here, but these are just suggestions, or typical operation. Grid number 1, control grid voltage. Okay, so looking for a bias of minus 7 volts. But in this case, we're doing it differently. We're using a cathode resistor. So here, cathode bias resistor, 180 ohms, and they're using a 150 in here, probably in conjunction with the lower plate voltage, maybe. The engineers are going to pick values here for these things. And this tube, 50L6. Wait a minute, something wrong here. Something quite wrong. I got the wrong tube. Is it not a 50L6? 50L6. Oh, okay. So what I was reacting to was I didn't notice the screen grid when I was looking at the schematic. There's a screen grid in it, and we should definitely check the voltage of that. So it's screen grid, typical operation of grid number 2. That's the current on the screen. Grid number 2. There we are. 125 volts. With cathode bias. So we should be looking for something like 7 volts dropping across a cathode resistor, or we should see the cathode is, sounds like I'm going to close my book. The cathode is 7 volts positive, something like that. 50L6. 50L6, and the cathode is pin number 8. Yeah. Pin number 8, RU 7 volts. I'm just going to put that up like that. Pin number 8 would be this guy right here, I think. So it's on the 15 volt scale, and we're reading 6 volts. I think that's all fine. I think that's good. So I think the deal here is that there is a small leak driving the grid voltage a little bit positive. It's still in the negative range relative to the cathode, but we're gonna replace this capacitor, and See what happens. There's two other older capacitors in here, but this one and this one, I'm gonna leave them for now. We'll just concentrate on this one guy here. Okay, I started pulling this guy out, and he's got lots of wire on him. Really jammed in there. So, I'm gonna tip this off. Enough lead here to test this capacitor. We're going to test it on this Heathkit capacitor checker. What this guy will do is he's going to put a DC voltage across the capacitor, and then I can vary that with this knob. And the magic eye over here is going to tell us everything. Let me see if I can cast a shadow on it. It's very hard to get this on the camera properly. Just such a quick test too. Okay, you can see that the pi, open it a little bit, you can see there's a pi open down here. Okay, so when I hit the button, this is the button, the voltage is going to be put on the capacitor. First there's a rush of current, and the eye will close because the eye is triggered by the current flow. But once the capacitor charges up, it takes just a fraction of a second. The eye should open right up like that if it's a good capacitor. There we go. There we go. Open right up. What's the rating on this capacitor? 0.01. 600 volts. So we can test this guy pretty high. Here we go. Okay, so it hasn't opened all the way. In fact, it's a little shaky there. What was that? You probably didn't see that on the camera. Loose connection. Doesn't open all the way. 250 volts. And you see can you see it's barely opening. It's definitely leaky. They all are. Brand new ones, you cannot measure the leak using this device, even with putting the top voltage on it. Brand new, no leak. But anything that's been in a radio for a while, it looks to be in really good shape. 0.01. Elmenco. 0.01. And I get the impression this has come from another radio. This is not a new. This was never a new part this was not a new part when it was installed. This was taken out of another radio. I'm gonna guess. 0.01. What I'm gonna do is I'm gonna check on the schematic, make sure 0.01 is the correct size, and then I'm gonna stick 0.01 back in there. And then we're gonna repeat that measurement, and then I'm done for today. That's the plan. Now something a little fishy here. You can see I've got the close-up camera aimed right into the radio there. So this piece of wire here is pointed right at the camera. This is the lead I cut that goes to the capacitor that I just tested. Now, my camera will focus on the right thing here. So what caught my eye here, I was just getting ready to solder in a new part. This may amount to nothing, but if you look, you see I'm touching a little piece right here. What is that? That is so close to this other terminal. Is that just a tail of wire, or is that a lead going somewhere? Use my finger here. Good. Well, looks like Is it just soldered to this other terminal right beside it? Autofocus running on this camera. Sure seems to be soldered to the terminal right beside it. I wish I could see it. That's not working. Is that a mistake? No, it's definitely soldered to that terminal. Probably not a mistake. Okay. I don't think that's a mistake. I think we're okay. Yeah, just a couple seconds have gone by. Boy, did I misinterpret the whole situation there. I'm worried about the little lead going down deeper into the radio, but in fact, that's what's really going on. I thought it's hard for me to. I thought this was soldered to this, and I was getting ready to connect here. That wouldn't have gone well. If you make a mistake putting a part in and you put it in the wrong spot, it can be very difficult in the end to realize that is what has happened. It can be very, very difficult. So lucky me, I should really cut that whole chunk of wire out of there and go right on the terminal. Oh, now you can see it very clearly. Yeah, very clearly. Okay. Certainty has entered the picture. Okay, we're ready for another test. Just watch those dim bulbs. Good. Didn't put this on. Live. Put that on live. Good. Okay. First, just take a look at the B plus again. So that's 130 there. 60 there. Okay, now we want to look at the grid voltage on the output. It's right here. Hoping to see nothing. Right, pick it up here. So I'm watching the meter. Nothing happening. The other side. Didn't it have, what it have, 60 volts on it? 35 volts on the other side. But on this side, if there's anything there, it's a tiny charge, and as soon as my meter contacts it, it's gone. It's not going up at all. So it'll be a small improvement in the operation of the radio. Not noticeable, I don't think. Not in its tuning or anything like that. Getting better. Every step of the way, I guess. So we have these two capacitors here to take a look at and consider whether it's worth changing them. But that's for tomorrow. I'm done for today. So thanks a lot for watching. See ya.